There's a bunch of different ways you can add or subtract polynomials. It boils down to combining like terms. You can add them vertically. You can add them horizontally. If I add them vertically, I want to add this polynomial to this polynomial vertically. I'll just stack them on top. I'll rewrite them so that the powers of x are all in the same spots, and then add together from there. We're talking about adding and subtracting polynomials today. So yeah. Oh, and multiplying. We'll get to some multiplying. That's not any different. So vertically, I'll just stack them vertically. Negative 5x to the third. And we'll add like term by term. Horizontal, I'll just find the like terms and I'll start at the highest degree and go to the lowest degree. So x to the third, 2x to the third plus 3x to the third is 5x to the third. 2x squared.
I think we just kind of like went through like wrinkle and can't read.
3x.
Are you just doing oh my god.
Stop complaining.
We're not complaining. We're shocked.
We're in awe.
We're in a revelation.
Subtracting term by term. So if I want to subtract this from this, first from the second, 3 from 10 is 10 minus 3. From is indicating we're going to take this subtracted from the second, so we'll write every term by term underneath. Negative 4x to the third subtraction, you could change the subtraction problem to an addition problem by plus and negative, so make everything, change the sign of everything inside. I recommend doing that. I don't recommend just subtracting term by term. That gets irritating. I would definitely turn this into an addition problem by, say, minus the same as plus negative 1 times all this. Distribute a negative sign inside. Or flip the sign of everything you see. That was a minus, it'll be plus. This was plus, it'll be minus. Was plus, it's minus. Was minus, it's now plus. And now add term by term. 7 x to the third minus 2x squared minus 2x's plus 15. Subtraction is the same as adding negatives. So just add by flipping the signs of everything that was inside. It'll be a much more efficient way and a way to make sure you make less mistakes. Goes first. So 3y squared minus 6y squared. 3y squared minus 6y squared is negative 3y squared. Negative 4y minus negative 6y. Negative 4 minus negative 6 is negative 4 plus 6, or plus 2y's. 7 minus negative 13 is 20. And check your work via the vertical method. So like FOIL type multiplying if you want. I don't like FOIL. I like using tables and charts. I think it's a little more efficient. You can do however you want though. If I want to multiply these two polynomials, I want to multiply these things. The same basic concepts for multiplying binomials apply. So if I want to use a chart to multiply these, I'm going to do the following. I'm going to write 3x squared plus 3x plus 5 going across. I'm going to make a column for each of these. I'm going to make a row for every term in my second polynomial. So my second polynomial is 2x plus 3. I'll make a row for each of those. And I'll multiply down and across. So 3x squared times 2x is 6x to the third power. Same base, add the exponents. 2x times 3x
Why?
is 6x squared. 2x times 5 is 10x. And now I'll repeat with the second row. So 3x squared times 3 is 9x squared. 3x times 3 is 9x. 3 times 5 is 15. And now I've got the 6 terms of my new polynomial, and I'll combine any like ones. If you set this up in standard form, you'll notice that the like terms are on diagonals. So let's see. I have 6x to the third. It's my highest degree. Plus, what are the x squared terms? 6x squared and 9x squared. 6x squared plus 9x squared. (16x squareds). 10x plus 9x are the x's. And the last term, the constant term, is 15. Six x to the third plus 15x squareds plus 19x's plus 15 would be the product of these two of the original polynomials. You can do it horizontally using a distributive property similar to FOIL. You can quote-unquote FOIL this if you want it.
Do we just do the chart?
Oh, I'd recommend that. If you wanted to multiply these horizontally, you'd use basically distributive properties. So think FOIL. Multiply this to each term. X to the third minus 5x squared. The middle term to each of these things over here. Negative 2x times x is negative 2x squared. Negative 2x times negative 5 is positive 10x. And then multiply the 3 to each of those. Plus 3x minus 15. And then combine like terms. And you get x to the third minus 7x squareds plus 13x's. Uh-oh. What happens if I have to multiply 3 different things together? What I'm asking you to do is to do x minus 1. I'm asking you to multiply these 3 terms together. When you need to, if you need to multiply 3 polynomials together, or more than just 2, multiply, pick 2 of them and multiply. Then take your answer and multiply it to the third. So for example, let's multiply, say, x minus 1 and x minus 1. If you FOIL this, you'll get the following answer. You get x squared minus 2x plus 1 is x minus 1 times x minus 1. And I want to multiply now this to x plus 2. Well, now that I'm here, now you can either do the horizontal, you can make a chart, get your final answer. I'm going to do x plus 2, x squared minus 2x 1. X times x squared is x to the third. X times negative 2x negative 2x squared. Two. So my polynomial multiplied out should be x to the third. Negative 2x squared plus 2x squared is 0. 1x minus 4x minus 3x's plus 2. Let's look at some special products. How about some patterns to help us multiply faster? If you multiply the sum and difference of a binomial, we already saw this. We saw this a little bit in the factoring from last chapter. If I ask you to multiply the sum and difference of two binomials, you get this nice pattern. You get a squared. This product is equal to the square of the first term minus square of the second term. If I ask you to square a binomial, well, there's positive or negative inside, you end up with the following. You get a squared twice of a times b plus b squared. So for a difference of cubes, or excuse me, cube of a binomial with a minus in the middle, every other sign will be negative. So it starts positive and then every other sign will flip. This is a consequence of what's called the binomial theorem. Has anyone ever heard of the binomial theorem before? You may not have heard of it at this point. We used to teach in the old AAlg2 series back before you guys were in high school. You'll see this again. You'll see that in pre-calc. It's called the binomial theorem. It explains. You can actually quickly write out the form of what this is to any power. Will let you kind of expand on that pretty quickly. So even if it was fourth power, the binomial theorem will tell you what you should write out. If it's fifth, sixth, however many powers.
So why did
Anywho, you can find some products relatively quickly with those patterns. Folks, you can find some products really quickly with those patterns. That's kind of why I gave them to you. If I multiply, if you have difference of two binomials, where there's one's add, one's subtract, the pattern says it's just a squared minus b squared. If a being the first term, b being the second term, so square the first term, square 5y, 25y squared, b being 3, so minus b squared. You could come to this conclusion without needing to use a chart or any of that stuff. 4a plus 7 squared, we could use the pattern of a squared plus 2ab plus b squared. A being the first thing, b being the second thing. So this better be 4a squared plus 2 times 4a times 7 plus 7 squared, which is 16a squared. 2 times 4 times 7 is 42a plus 8, 56. 56a plus 49. 2 times 4 is 8, 8 times 7 is 56. You can use the difference of cubes here, excuse me, the cube of a difference. That's A, that's B. So the pattern is A to the third plus 3a squared b plus 3ab squared plus b to the third. Or replace a with mn. So this is mn squared, excuse me, third power, plus 3 times mn squared times 6 plus 3 times mn times 6 squared plus 6 to the third power. and use your exponent rules. So mn to the third is m to the third n to the third. 3 m squared n squared times 6, or 18, times n squared n squared. 3 times 6 squared. 6 squared is 36 times 3. 36 times 3 is, top of my head, so 108. 108 mn. 6 to the third is 216. Is it 6 to the third is 216, correct?
Would it be negative 18?
And it's mn minus 6, so the pattern should be the second and the last are